Hi guys, so I did a recent video on this little AC measure module over here, and I had in mind right from the beginning to use it with a Variac, like you see one over here. This is just a cheap Variac, serves my purposes, but it has a very inaccurate little linear display on there, and also on the top you can see it has like a dial for voltage, but also it is very inaccurate. And it says 5 volts, it might have 8 volts on it or something like that. So I decided that I wanted to have a digital display which shows the voltage and the current, and I could actually build it into this thing. There's room over here, but I decided not to do that because if I make it external, and I have already laid out a little cover for a box here. This thing only has an output for a US plug, and I also wanted to be able to have output on some banana sockets. So this is going to give output on the banana sockets, and I've been using a TTGo board with a display on it, and I put it in here behind a little clear plastic. But in future I'm actually going to remove that. So right now I've just put it, glued it in there with some hot glue, which I can easily remove a little bit of hot air. And I'm going to be mounting a bigger display on here, and I'll be putting a different kind of microcontroller inside, but the code will be pretty much the same. So that's just a future thing. I've got a display on order already, but it'll take, it's coming from China, so it'll take 3 weeks to get here, no doubt. Still, anyway, so we've evaluated this little AC measure device in a previous video. It's well built inside, it's got safety features and so on, but as is not uncommon with Chinese products, the software, in this case the firmware, leaves to be desired. Now, to be fair, I guess this thing has not been designed for what I'm actually exactly what I'm using it for. It's if you have this hooked up to your power, 120 volts in the US or 250, 240 volts in England and Australia and so on, and you have something hooked up to it that draws, like 80 milliamps or more. It's actually I think 100 milliamps is probably or more is probably at that rate it is reasonably accurate, and it will report the current and voltage and watts that is being consumed and so on. But I want this thing to work with a Variac, and Variac can go right down to 0 volts, basically low voltage. And I have found that this thing can actually measure the voltage accurately, even at like 4 volts or less. But the current and the power and so on, and there's a power factor there as well, it just goes berserk. It just comes back with strange values. Now, if I was writing the firmware for this thing, I would have taken care of that by making some adjustments inside and just not outputting if I can't determine the current accurately or the power or whatever, I would have just come back with a code saying, undetermined or something like that, but the voltage would always be right. So in any case, I've written code in Arduino in order to actually take care of that, but unfortunately now the chip in there, I think if I remember correctly from the data sheet, it says that if it detects less than 50 milliamps, it actually shuts down the measuring chip. But the M5 stack people that made this device have decided that when the chip says, okay, I'm shutting down, I can't measure this, to shut the whole thing down. So in order to overcome that, I have found that there is actually on the original circuit and this is it here. I guess it might be a little bit blurred, but it's not too bad. There claims to be a jack 1, and these 5 little pins are actually right underneath this socket over here. So when you open it up, I have actually soldered up some little wires, because I thought myself maybe I can use that this NRST, that's negative restart, goes to the microcontroller here. I thought maybe I could just pull that low and the microcontroller might reset itself, but that didn't work. So that was so the only option we have is just to simply turn the power off and turn it back on, and when you do that, it restarts the microcontroller, and it tends to work for about, I don't know, 15 seconds. If it detects less than, in my case, at 120 or 30 volt maximum, it seems to be locking out at below 80 milliamps. But somebody else has already said that they're probably in England or something, they've got 240 volts or so, and he says it works right down to 42 milliamps. But nevertheless, even at that rate, the other values, the current and so on, is not accurate and unreliable. So I've actually, in the code, I'm taking care of that. We'll have a look at the code soon. So in any case, this is what we have. I can make it work by some code in the Arduino to take care of some of its shortcomings for what we're using it for. So I've got a little box over here that I'm going to be using, and I have already cut the holes and mounted sockets over here, and I'm going to be running it off a lithium-ion cell over here, which means that we've got to be able to charge it. So I'll put a little socket here for 5 volts, and I have a little cord over here. This is actually USB to a little barrel jack, which plugs in there, which we're going to be using. Then we have, as I said, we've got the lithium-ion cell there, and this here, I went to my junk box as usual, and I picked up a bunch of wires. Now I won't be using this one, so this is the one I'm going to be using. This is going to be the power in, so that would plug into the Variac, and that's going to be feeding power into the AC measure unit. Then on the way out, it's going to be connected to these banana sockets, and it is going to be feeding this contra plug over here. I actually created this little board over here, a little piece of perf board. Now it has a MOSFET on there for switching the power on and off to the AC measure module, and it has some leads over here for connecting to the AC measure module to the microcontroller, the TTGO board inside. And it has some capacitors on there, 100 nanofarad and a 100 microfarad. That's kind of necessary because in order to use this lithium-ion cell over here, it needs to provide power to the microcontroller, the TTGO board, but it needs 5 volts, and so does the AC measure board. So, and we need to be able to charge the battery. So I'm going to be using this little board over here, which is actually one that I kind of like because it has these 3 or 2 chips on there, and a little boost controller over here, which are well-known devices that actually work well. It provides protection, overload, and it is able to charge the battery while it is providing an output voltage, and which is 5 volts. Some of those little boards, like one I've looked at a weird one with a little switch on it lately, that and it's not uncommon for some of them to do that, is that as soon as you plug in a USB cable to charge it, it now actually outputs the USB charge voltage instead of the voltage from the boost regulator, and which is often lower than 5 volts, and I don't like that. And this one here seems to continue to be able to output boost voltage, even though it's charging at the same time. So we're going to be using this one, but nevertheless you can actually charge while you're using it. But nevertheless, I wanted to have a charge mode where it is just this boost regulator and lithium-ion cell charge board is actually only connected to the input, so it can actually charge. And I also want to be able to switch off the thing completely where the lithium-ion cell is not connected to anything. Now this thing, you know, it draws, I don't know, not very much current, and the lithium-ion cell probably would last a long time, even if it is not, if the power is switched off to these two devices. But I decided I always like to have them be able to disconnect altogether. So I originally thought I would use this, just like a switch like that, with the center off, and there would be one way would be charging and the other way would be on, basically, and the mid center would be off. I did not have, I thought I had some of those in my box, but they were single throw, so I had to use this. I got a 4-way slide switch over here, and the 2 outside positions are going to be off. That's going to be charged and that's going to be on. So I'm going to use that, and that's going to be wired up a bit differently like that, but I would normally use a switch like that. It would be a toggle switch like this, but it would have a center off as well. Okay, so that's the story on that. So now the AC measure board, it has an SCL and an SDA I2C connection to the TTGO board, which on that particular board you use IO, GPIO pin 22 and 21, and of course it needs +5 and ground. And in order to reset this AC measure, I've actually connected a MOSFET to the GPIO pin 17 in this case. It doesn't matter which one you use as long as you adjust it in the code. And this is this MOSFET here is a special one, which is actually aimed at being run from chips directly. Let me see, display capture is over here. So this is an RFP30N06LE. I don't know why those names have to be so long. I guess it tells you that it is 30 amp at 60 volts or something. I don't know. Anyway, one of its features is that these transistors can be operated directly from integrated circuits, and another important factor is that, as you can see here, the gate threshold voltage goes from 1 to 2 volts. Standard MOSFETs usually have 4, 5 volts or maybe even more for some of the high-powered ones. And of course we are outputting from the TTGO board there we are outputting logic levels, and I don't even know, I think it's 3.3 volts logic level for high, and less than 1 volts for low. So this particular type of MOSFET is ideally suited for that kind of thing. That's why there's no resistors or nothing, it's just directly connected. And so this is kind of the circuit, and so I'm now going to wire it up, and once that's done we will go and check it out. Oh, and of course I'm going to I've decided not to use this little case over here. Those wires are very skinny, and I'm going to put some little tags on there, some nickel strips that I can solder to. Okay, so we're going to try to let's see, that's pretty good. Spot weld this on. Very good. Okay, so now that will do. That's good too. Okay, so now we got two little tags spot welded onto this cell over here. So now I can actually solder on some wires. I don't like soldering directly to the cells. Some people do that, and I've done that in the past as well, but I don't know, lithium-ion cells can be dangerous when they've been abused. So okay, put this away. Let's tin them up. Okay, next one. I think a little bit of this flux will help there. It's not taking right to the edge. Yeah, that's better. This one was okay. This is old recycled wire, so I always like to put a bit of flux on there. A little hold it with that because it is not easy to hold. Right. Okay, I'm going to put a little bit of tape on there. This is this stretchy Tessa tape, which I like. It's not plastic. It's like a cloth type thing, but it is really sticky and quite strong. And it insulates, so I don't want this, touching anything. Little piece to actually stick it to the cell itself. There we go. Another piece on the other side, and that should do it. Alright, one cell ready to go. Okay, so I've made up a little wiring harness for this thing, and this is going to be the output socket, and this is the input over here. It just has a plug on there, which you can plug into the Variac or just into the mains power if you want to. The green wire is actually ground over here, which is not actually used by the AC measure, so it just bypasses it. So I have the ground connected to the ground on the output plug socket rather, and we've got two of these, the active and the neutral is actually going to two more wires, and these wires are actually going to be mounted in here. Now it looks like in North America they mark active as L, where I studied electronics, we used A for active, but anyway, I don't know what the difference is. So this one is actually going to go into here, and the white one is actually the neutral. So I'll get back to front, don't I? This is there, and the neutral goes over here, like so. And we can then screw them down. Now, the one thing about these ferrules is I bought these, we'll discuss that for a second here. I bought these in a kit. Came with some pliers and a container with a variety of these little ferrules in it, big ones, small ones, and so on. And there is actually, it came with a pair of crimping pliers, which, as you can see, is square, so it makes a square pin, which is great for when you are plugging them into some of those things that has a screw to hold it down. However, these guys over here are going to be soldered into these sockets here, and there's a round hole in there. So I prefer to have round ones there, and indeed you can actually get these. They're actually hexagonal, so they make a rounder pin. So I've used those on these here, since they're going to be soldered into these round holes on these sockets over here. So you might find that interesting. Now, we're talking about active and neutral. I thought we discussed a little bit about what the Variac actually, the wrong piece of paper. The Variac actually is a transformer, but it's called an auto transformer. And a normal transformer you might have seen in circuit diagrams is like this. It has separate windings. There might be AC coming in here, like maybe 120 or 240 volts, and there might be 12 volts or 18 volts or whatever it is coming out on a secondary isolated winding. So this is an isolated transformer, which is normal, but on the Variac you want to be able to vary the voltage. So they actually, it more or less looks like this. You have a big toroidal coil which is connected between neutral and active on the mains power, and then there is a slider which slides across the coil, and obviously if it's down here is low voltage, and if it's up there is high voltage. And you might notice that there is some extra winding there beyond where the active is there, and that's why most Variacs, the one I've got, goes up to 140 volts with 120 volts in. So it's actually the last little bit actually steps up the voltage a little bit. However, what is important about that is the power that comes out of the socket, the so-called neutral, actually is connected at the power board coming into your home or the building to ground, to earth. So that's why if you measure the voltage between earth and neutral, there should not be any voltage there. But if you measure between earth and active, you will get the full voltage. So therefore, when you're using a Variac, you have to be aware of that there is one of the outputs is connected, the neutral is connected to the earth, and if you're using some equipment like an oscilloscope or something like that, the ground on the oscilloscope is actually connected to the earth strap. So if you were to put the ground of an oscilloscope, and some of the other test equipment is like that, to the output, you will fry your oscilloscope. So that's why it is quite common to use a transformer like this, an isolation transformer, that you would connect between these two pins here as well. And indeed I got such a thing there, so that then it's a one-to-one input output. So if it's got 100 volts in, there will be 100 volts coming out, but the 100 volts then will be isolated, and both ends of the winding there, neither one of them will be connected to ground. So then you can actually, with old equipment especially, like valve or vacuum tube equipment and so on, they usually had the whole chassis grounded, so that can be tricky. Alright, so that is what we have so far. Now it is time to go and wire in. This thing I don't have to do anything with, because it plugs into the this one plugs into the AC measure device here, and those guys here, I put DuPont pins on there, they plug into the pins on the TTGO microcontroller, so I can just plug them in. I did that because I'm planning to remove this microcontroller when I get the other display, as I explained earlier, which I'm planning to mount on the top of here at some stage, and then I will use a little microcontroller in that it doesn't have a display on it. Which one, I'm not sure yet. Okay, so now we've got to wire up the switch. and this is how I'm gonna wire it up. But if you want to do something similar, don't forget that I'm recommending just to get a double pole switch with the center off, and then you would just have 6 pins to wire up, or 5 actually. There's one with no connection there. But because I didn't have one in my supply and I wanted to finish this project, I'm using this switch over here, which is actually a 4-position switch. This is common over here, and then 1, 2, 3, 4 outputs, and I'm not going to use the 2 end ones, so therefore I'm actually using it just like it says on this diagram there. You can see those 6 pins over here. That's how these 1, 2, 3, 4, 5, 6 pins are going to be wired, and those are going to be left unconnected, so that's off. Alright, so I'm going to be doing that. I will solder it up off camera because it will be time consuming and it's kind of a bit boring to watch. If you've seen one wire being soldered, you've seen them all. So I will go and do that now. I've got the unit plugged into the Variac, and the Variac is showing 0 volts right now on that little useless analog voltage display, but it is actually outputting 3 volts. I've got nothing plugged in right now, but I will plug in the heating element, and if I increase the voltage here, at some stage, if it gets over 80 milliamps, it starts to display the values here. So I can increase the voltage just over 1 amp, wind it right up, 140 volts, nearly 2 amps. And if I switch it off, it will not display anything now because the thing is off, and the voltage, it internally always generates a small voltage like 0.076 volts or something like that, and but we know that that's invalid, so there's no point in displaying that. Turn it back on, and if I hit the mode button over here, goes into the alternate mode there, where it shows all the values, power, and so on. It's always hard to focus in on those little LED displays, but anyway, I turned down the intensity there. You can kind of see it, and if I hit reset, reset itself, go back to that mode, hit reset. Okay, so everything is working now. So let's have a look at the code. There's a quick code review here. I have a reminder over here that with that TFT ESPI library, there's a user setup H file that you have to edit. Of course, I've done that. It basically has some constants in there, similar to like the defines in here, where you would define the pin numbers used for the accessing the display and all that kind of stuff. So unless that is set up right, it won't work. Some comments here about how this thing is supposed to work, and the kind of anomalies and things that we have to try to cover up, and the fact that we have a MOSFET connected to one of the GPIO pins, and in fact the ACM reset pin 17 is used for that. There's no magic about that pin number, it just happens to be right next door to the pins 21 and 22, so I was able to put a three-way DuPont plugged into the pins, so that was convenient. 17 is right next to 22 or something like that. So the buttons on the TTGO board are connected to GPIO 0 and 35, and then we have some offsets here into that text mode array that is defined over here, because we have those two modes. One mode where it just shows voltage and amps with a larger font, and another mode where it shows all four in a smaller font. And these values over here, as the comment shows, there is a pixel offsets, the horizontal offset, the X offset, the vertical offset, the Y offset, the actual text size, the start of the value column. In mode 0 we got two columns, we've got a prompt and values. In mode 2 we do not, but that is where the volume column hangs out. The actual width of that column, the column height, and the actual line padding. As we go from line to line, a few pixels have to be put in between so that they don't touch. Similar as you actually see on the screen here, you see the 0 and the 1 over there there's a little bit of blank space there. So that's what that's all about. This is a kind of a debugging thing. I put auto restart. If it's defined, it starts automatically, because as you know, from the previous video, the AC measure module will actually stop. It'll shut itself down if there is less than, on mine it's 80 milliamps, but I believe I've heard somebody commented that he's running 250 or 240 volts, and he can go right down to 42 milliamps apparently. So we have to deal with that by actually doing a hard reset on it, by cutting the power and putting it back on. Then we have a few parameters here, because especially at low voltage and low current and so on, that comes back with erroneous values that are not accurate, and there's no point in displaying those. They will just jitter around. So if the voltage is less than 0.99 volts, we just don't display it. Of course these can be edited, you can make them larger, smaller, whatever the use case is. The maximum voltage should actually never be more than 250, because that's the maximum voltage that it can operate on. The maximum current should never be more than 10 amps, and the minimum current, that on my unit I set to 80 milliamps. If it's showing less than 80 milliamps, I'm just not displaying the current, because it's probably erroneous. And yes, the I2C pins that are used for the AC measure module on the TTGO board, and a couple of local variables here that we're using: the actual font number, the default mode is going to be 1, and a place to actually store between readings the wattage, the power voltage, the power value that we can use in the calculations. And in mode 1 we actually store what was last displayed in these character arrays, so that we can compare them, and if they haven't changed, we don't update the display, because it tends to flicker a little bit otherwise. And then we have some functions here to deal with the sensor power. As I said, pin 17 is directly connected to the gate of the MOSFET, so when it is high, it will turn the power on to the AC measure module. If it's low, it'll turn it off. So here we can actually pass in a Boolean value saying sensor power true or false, so it will be on or off, and a small delay in order to give the AC measure sensor to register the the change. Then we have a little function here to check whether one of the buttons was pressed, either button 1 or button 2, and it will return 1, 2 or 0 if nothing is pressed. Then we have a function here which goes beyond that sensor power one here, that actually toggles it on and off and does an additional delay to give the AC measure module time to power back up. I'm not sure if that is actually necessary, but I put that in there anyway. Could fiddle with it and reduce it and see what happens. Maybe even remove it. Okay, so then we have a bunch of functions here: show, clear screen, show line, show text at a X horizontal offset, show text at X horizontal offset on the current line, but then move the cursor to the next line. And then we actually have the big show results after we read the AC voltage, the amps, the watts, and the power factor from the AC measure module. Then here we display the information, and this is where we do a lot of the checking to see whether the values are correct, whether we want to display them or not, and whether we want to update the display or not. So if we got garbage, which does happen occasionally, then we will define the voltage to be undefined if it was invalid, which is actually a negative value or 0, or if it's larger than the maximum voltage, or if it's less than the minimum voltage, it's just voltage will be undefined. Likewise, the current will be undefined if the current is less than the minimum that we want to see and larger than the maximum. So if it is not in that range, then the amperage is actually not trustworthy. So if the voltage is undefined, we are going to is not undefined rather, then we're going to display the voltage. However, if the current is undefined, then we don't display the current either. But if it is, if the current is defined, then we actually check the wattage, because it is noted, especially at lower currents, that the wattage is actually out. We know that the current and the voltage is relatively accurate, but the wattage appears not to be. So therefore, we actually store the average of the watts. We take the current watts and the previous power value and add them together and then divide them by 2, so then we get an average, and then we store that back in that PAC value there. Then we calculate the actual power according to Ohm's law, amps times volts. Then we check if the power that is being reported and the calculated power are they within 10% range. If it is within 10% range, then it can go as it is, but if not, then we will actually use the calculated value, and we will show that on the display by putting a little star after the W for watts to show that we had to calculate it, because the device didn't come back with a value that made sense. So that's one anomaly that we fix that way. Then depending on the mode, we will either display all 4 or just the 2 values. There's a slight difference in the 2 modes here, that's the way that they work right now. We have 2 columns. In this mode we show voltage, and then we will, if the voltage is undefined, we just show dashes there, otherwise you will show the value there. and we are actually doing the same thing for the current, the power, and the power factor. But they have also, if the current is undefined, then the other three don't make any sense either, so they get dashes. But if the mode is 1, then we actually want to keep the display as steady as possible. Every time you update the display on this TTGo thing with the TFT display that it has, if you display a space, it actually doesn't do anything. It just leaves what's already there in place. So therefore you have to go and clear the area that you're printing potentially new text, and of course that when you do that, that causes flickering on the screen. So therefore we actually will create the values to be displayed in a string before we display them, to double check if we actually need to display them or not. So if the voltage is undefined, of course we go for dashes, and otherwise we will use decimal value with 2 decimal places and so on. Then we actually store that a value in the over here in a global variable, so that we can actually therefore test it. So if the new line is not the same rather as the old line, if the old line 2 is not the same as the line 2, or if line 1 or line 2 are empty, then we will display it. So here we've got to fill a rectangle that actually clears that space where the values are, and we can show the value and put V after it, and the amperage and put A after it, and as I said, copy the line that we have to that line value and line 2 value, that so we can compare them next time to see if the display needs updating. And here is a couple of functions that are used for resetting and for enabling the AC measure module. Wait for sensor, waits for the AC measure module to initialize, and optionally it can do it silently, which it does if it shuts down while it is measuring and we didn't push the reset button. So therefore it can do it in the background without us knowing about it, so the display won't be upset, and therefore you will pass in false there, and it won't be displaying waiting for sensor and stuff like that. This is the reset, which actually calls that wait for sensor thing, so it actually again has the same thing, silent or not. If it's not silent, it displays resetting on the screen. However, if for some reason the wait for sensor thing comes back false, it wasn't able for some reason or some error condition, then it will display sensor failure on the screen. And if it is being reset, then we set line 1 and line 2, those values that we compare in the display, to 0, otherwise the display may never be updated, and it'll just stay clear because we do a clear screen. And this is the standard Arduino setup. So we're just setting up some pins over here for input output, and initializing the TFT display. So we then have another function here that actually does the restart the AC measure unit, and it calls reset silently, and or well, whatever was passed in there, and it returns the sensor get ready value to see whether it's ready or not. Then we have the standard loop over here, which actually is the thing that looks for the buttons if they've been pressed. This is the mode button. If the button is pressed, then it switches the mode, and again it sets the line 1 and line 2 values to nothing so that the screen will be updated if we are in mode 1. If button 2 was pressed, then it's reset. So now we're going to restart the AC measure unit, and of course we passing false here because we do want to see the message when you push the button to acknowledge that you've pushed reset and see the messages. If it wasn't ready, it's gonna because the AC measure unit shut down or something because there's not enough current or whatever it is, then it will do a restart as well, but now it's going to do it silently in the background. And then, so if ready is 1, we can actually get values from it, which we pick up over here, and then we show the results. If it came back with voltage AC is 0, which occasionally it does when it is first powered up, because it's not ready to come back with the value yet. These are all limitations in the firmware, I think. Then of course we set them all to invalid. And a short delay if mode is 0, so that the screen doesn't flicker too much. But mode 1 is already taken care of with that checking those line values. And that's basically the code. So if you guys would like to have this code, any of you, put it in the comments, and I'll stick it on GitHub so you can download it if you want it. Other than that, that is what we have. So I have, I think, a successful build here. The little unit works. I can actually plug it in not only in the Variac, but I can actually plug it into the normal power outlet and plug something into it, and I can monitor the voltage and current and power and so on if I want to. So it can work as a power monitor as well. I'm toying around with the idea at some stage just for fun to actually, since that ESP32 modules tend to have Wi-Fi built into them, to actually hook it up to the Wi-Fi and make it work as a little web server, and so you'd be able to actually access it via maybe cell phone or a computer, and actually control it from there and see the values and so on. That will be fun. If I do such a thing, I'll do a little video on it. And but I've got some other projects that I'll be working on first. If you like this sort of thing, then please don't forget to subscribe and like and all that sort of stuff. That would be helpful. And that's it. So I'll see you guys later. Bye-bye.